So today we're going to solve trig problems involving angles of elevation and depression. So let's establish what they are to begin with. Now, angles of elevation is an angle that's formed by the horizontal. So this is the horizontal line here. Like, imagine yourself looking forward, just straight forward, your neutral position. And then suddenly you have to look up to something. Now, the angle that you have to tilt your head to look up to an object up above here, that angle is called the angle of elevation. So it's formed by the horizontal, which is that first line that I drew here, and the angle in which it took for you to look up at that object. So angle of depression would be the other way around. Angle of depression, once again, it always has to start from the horizontal, and this time, instead of looking up, you're looking down like you're depressed. So as you're looking down, you're forming an angle between where you would normally look at, so the horizontal, and then the angle that it takes you to look down at that object would be called the angle of depression. The most important thing to note here is that angles of elevation and depression is always measured from a horizontal. Okay, there always has to be a horizontal there to be considered an angle of elevation or depression. Okay, this bit is really important because I see a lot of students stuff this up and put the angles of elevation and depression somewhere else where it's not supposed to be. Another thing to note is that if this was you and you were looking down at a ladybug, the angle that you took to look down at the ladybug from the horizontal is the same as the angle in which the ladybug has to look up at you. So these two angles would be exactly the same in this scenario here, and you should know that because these are alternate angles. We've got a parallel line and a transversal, and this forms a Z shape, and this Z shape means that the two angles here should be equal. Okay, that's providing that, you know, the two objects are placed against each other like this. Okay, and don't forget, it's always measured from the horizontal for both of them, even. Now let's try and, I've already talked about this. So the angle that it takes for you to look up at something is the same as the angle it takes for the same object to look down back at you. So this Z shape, angle of elevation, is equal to the angle of depression in the same scenario. All right, so how to tackle these angle of elevation and depression problems? First, you will need to draw the scenario if it's not drawn for you. You need to locate what you need to find, and then you're going to solve it using SOHCAHTOA, the trigonometry ratios. So let's do it for this diagram over here. Now it says here, find the angle of elevation of the tower measured from the road as given in the diagram. So remember, it's saying angle of elevation of the tower from the road. So you start from the road and you want to look up to the tower. And so the angle that we're looking for is this one right here. So I'm going to call this X. So the biggest mistake people tend to make is putting the X in the wrong place. Okay, this is obviously a right angle triangle, so I'm just going to draw it in. But it's always measured from the horizontal. Some people would put it, for some reason they'd put it here. It makes no sense to put it there because there would be no, unless you form a horizontal here, this angle will never be an angle of elevation or depression. And I've just messed up my page. So to solve this problem, now that we've established what we need to find, we're going to see what we actually have. So if right here is the right angle, then this would be the hypotenuse, and we don't have that. We don't have any values for it. We're not even looking for it. What we do have is the 20 meters will be our opposite. Oops, it's doing funny things. This will be my opposite, so my O, and down here would be my adjacent, my A. I'm not sure what's going on with my mouse. Okay, so O and A, the ratio that we need to use would be tan. So theta is equal to, we're looking for an angle, so we're going to use inverse of tan. That's a -1. Opposite over adjacent. I'm not sure why it's making funny lines, but hope you understand it anyway. So theta is equal to the inverse of tan. And opposite in this case would be my 20. And my adjacent would be my 150. Now they're in the same unit, so I don't have to convert anything. And all I do is type that into the calculator. And you probably see it better if I just typed it in the calculator in front of you here. So I'm doing inverse tan, 20 over 50, 150, 20 over 150. Oh, can you see? The answer is 7.59. And the answer obviously will be in degrees because it's the angle that I'm looking for. So it's only a very small angle, okay, between the ground and looking up at the top of the tower that's 150 meters away from you, and the tower's 20 meters tall. Let's move on to the next example here. This is going to be fun. So we need to draw out a diagram. It says the angle of depression from the top of a 35-meter cliff to a house at the bottom is 23. How far from the base of the cliff is the house to the nearest meter? So let's draw out what we've got, and let's hope my pointer works. So I've got a tower. Okay, this is my tower, and this tower is 35 meters tall, 35 meters. And it says the angle of depression from the top of the tower. So if you were here, if you were looking at from the top of the tower, sorry, it's a cliff, my bad. So it's a 35-meter cliff, and you're looking down at a house at the bottom. So we've got a house at the bottom. And the angle of depression from the top of this tower down to the house is 23 degrees. It's asking for the base of the cliff. So remember, to establish the angle of depression, we first have to have a horizontal. So you're at the top of the cliff. So if you're standing here, your neutral gaze would be right here. This is your imaginary horizontal. It's not a very straight line, but you get me. So this is your horizontal. And now you're going to look down. So you're going to tilt your head down to look at the house down here. So this angle that you have tilted your head down apparently is 23 degrees. Let's hope I can write this in. 23 degrees. Cool. Now it's asking, what it's asking for is how far from the base of the cliff is the house to the nearest meter. Well, the base of the cliff to the house is going to be this down here. So I'm going to call that X. That's what I'm trying to find. Now, we can simply use trig ratios to determine what this is. And what I'm going to do now, using a different color, is I'm going to highlight the triangle that I'm going to use to solve the problem. So I'm going to use this triangle here. Whoop, it's not very nice, but this is a triangle that I'm after. I'm looking for X. I know that that's 35 degrees. And another thing that I also know is, because of the alternate angle rule, the Z shape, is that this down here has to also be 23 degrees. Remember, we said before, if something is looking down at you at an angle of depression of 23 degrees, then you'd be looking up at it at an angle of elevation of 23 degrees as well. So, because you can see the Z shape, these are alternate angles. So now we've got our triangle, and what we're going to do is we're going to type in, or write down what we've got. So if this is our angle, 35 would be our opposite. So I'm going to put an O there, and X would be my adjacent because it's right next to it, and it's not the hypotenuse because the right angle would be right here. And so we once again have to use the ratio tan. So tan, inverse of tan, remember it's opposite over adjacent. So opposite in this case is 35 over adjacent, which is X. And why did I do that? I'm so sorry. We're not looking for an angle here, we're looking for a side. My bad. We are still using the same ratio. So we're just using tan, 23 degrees. I'm so sorry, guys. Tan 23 is equal to opposite, which is 35, over adjacent, which is X. Okay? And all we have to do now is we can switch. Remember, we said from last lesson, if the unknown's at the bottom, we can just switch places with them. So x is equal to 35 divide by tan 23. And all we have to do is type it into the calculator to find out our answer. And it would be in meters because it's given to us in meters. So 35 divide by normal tan 23. 82.45 meters. So the distance between the house and the base of the cliff, according to our calculations, is 82.45 meters. And that's all there is to it.